Hello and welcome to Functions 2.3, Identify Key Information from a Graph. So this is going to be pretty similar to the lesson that we just did, the one before it as well, where we're going to read the characteristics of a graph and answer questions. Okay, and these questions are going to be, I guess, different themes. So the graphs are going to be mapping out different types of scenarios that we have in our world. So some may get confusing because the scenario itself you may not be familiar with because it's something that you might not have experience with. So hopefully I can explain the characteristics that you see in the graph so that if you ever see that characteristic again, then you know how to read it and you know what to look for as far as how to answer questions that they may throw at you guys. Okay, so this first one is about Jasmine, and it's a graph that shows Jasmine's distance from home as she sets out at noon walking to meet a friend. Okay, so let's see what our questions are. So first question, where was Jasmine at noon? Okay, so the hard part is the students usually think of noon as a 12 as far as a number on your x-axis, but you got to make sure you guys understand your story well, where it says she starts walking at noon. So when she starts walking at noon, that's going to correspond with the 0 on the x-axis. So when it says where was she at noon, well, let's look at where she was as far as where the graph is saying she was at 0, at time frame 0, and it shows her pretty much at the origin, at the bottom, touching the x-axis. So at the bottom of the y-axis, and since the y-axis stands for distance from home, we can assume the bottom of the graph, right? The origin, the very, very bottom, that point that is where the graph starts is home. So I think I'm going to guess home as a guess. And yep, I was correct. Jasmine was at home at noon. Okay. When was Jasmine farthest from home? So you want to look for a part of the graph that's actually really, really high, because the higher the graph is, the farther from home she is. So where is the graph the highest? And you're going to hopefully say, I think she's the highest. Let's change this to a writing utensil. She's right there. That's the highest right there. And what time does that correspond to? So if 0 is noon, we can assume 1 is 1 o'clock and 2 is 2 o'clock. So we're going to guess 2 p.m. So let's see. Is that correct? 2 p.m.? Sure is. Okay. And letter C. Approximately when was Jasmine 3 miles from home? So 3 miles. Where is 3 miles? The 3 miles is going to be everywhere along that 3-mile valley on the y-axis. So we're going to go straight across from 3, and it's going to hit the graph in 2 locations actually. Okay, so let me get rid of this previous dot because I don't want you to think that this red dot is going to be connected to the problem that we're currently on. So it says when was she 3 miles from home? So we're going to put a dot at 3 miles from home and another dot at 3 miles from home again. Yeah, so there's 2 occurrences where she's 3 miles from home. So I guess when she's walking to her location to meet her friend, she hits the 3-mile mark, but she keeps on walking, so she gets farther than 3 miles from home. And then when she has to go back home, she hits the 3-mile marker again. So I guess that's the reason for 2 occurrences of 3 miles. Okay, so the first occurrence is halfway between 1 and 2. So if it's halfway between 1 and 2, I guess we can assume it's 1:30. And the second occurrence is also again halfway between 2 and 3. So I guess we can assume that's 2:30. So let's see. Are the guesses that I came up with correct? Sure is, 1:30 and 2:30. Okay. Alright, so I'm going to go ahead and erase these dots already, because if I got to put more dots on the graph, then I don't want you guys to get confused with the red dots that are there now. Okay, so when did Jasmine return home? Okay, so if she's at home again, that means she hit the x-axis. So the only time she hits the x-axis is, well, here, but it's saying return home. Yeah, she didn't even leave home, so I can't really count that first dot. So I actually should erase that dot. So that dot doesn't count. So when else do we have the graph hitting the x-axis? Well, it hits it right there. Okay, and approximately what time is that? Well, we have the 4, the time frame 4, and then it looks like we're one more box after that. So since my graph looks like it goes in intervals of 30 minutes, we can assume that's 4:30. Would that be a good guess? Well, let's see. Let's see what the answer tells us. Yep, 4:30 is good to go. Okay, and the last question, let's see what that says. Describe what Jasmine might be doing between 12:30 and 1 o'clock. So where is 12:30 and 1 o'clock? So 12:30 and 1 o'clock is right there. So what's happening right there? Okay, well, first of all, we know the graph is flat. And because the graph is flat, that means that she's not moving. Well, she's not like totally like a mannequin and stuff, but she's not getting any farther from home. She's not getting any closer from home. So she's staying in one spot for like 30 minutes. So what do you think she might be doing for 30 minutes? So that answer can vary. Yeah, we know she's not getting farther and closer from home, but we can kind of make up stuff as far as what she might be doing, like maybe eating lunch or taking a nap under the tree or I don't know, playing on her phone. Who knows? Okay, so let's see if our guess is correct though, as far as not getting any farther or closer to home. So let's uncover this box. Let's see what it says. So Jasmine stayed in the same place. Yeah, that's kind of like what we said. And maybe she's eating, or yeah, she could be texting on her phone. Yeah, because kids nowadays, they like to text. Okay. All right, so let's go on to the next problem. Okay, so this next story is about Leilani. She drives from her house to a nearby store. The following graph shows Leilani's speed in miles per hour, T minutes after leaving her house. Okay, so let's see what our first question is. So when did Leilani reach her maximum speed? Okay, so maximum I guess we can think of as her fastest speed. Okay, so when did she get to her fastest speed? So let's look for the highest point on the graph. And I think that would correspond with a dot that's right there. That's the highest point on the graph. And at what time frame does she reach that speed of, ooh, what speed is that anyway? Looks like it's like 35 miles an hour. Okay, so at what time frame are we looking at? And this problem's a little bit different. Okay, so you got to look at the label. So this is going to be time in minutes. So 2 minutes after she leaves home, she reaches her speed of 35 miles an hour, which is the fastest she gets on her journey to the store. So I guess we could say at the 2 minute time frame, it would be a good guess. Well, let's see, what does it say for our answer? Yeah, at t equals 2 minutes. So that's my time frame that she reaches her fastest speed. Okay. All right, let's see what's next. So at what was Leilani's maximum speed? So kind of erased it out a little bit too quickly, so I'll put it back real fast. And I kind of already said what Leilani's maximum speed or fastest speed was earlier, right? And it corresponds to 35 on the y-axis. So 35 miles an hour is her maximum speed. That's my final answer. Let's see if it's correct. Sure is. Okay. So this time I'll erase the dot, and I don't think we're going to use that dot anymore. So let's see. Next problem. When was Leilani traveling at 30 miles an hour? So let's look for 30 on the y-axis. It's right there. And let's go straight across till we hit the graph. So we hit 30 right here, and we hit 30 right there. Okay, so she hits 30 miles an hour twice during her journey. So it says, when was she traveling at 30 miles an hour? Well, let's see where this first dot lines up with, and it lines up exactly smack dab in the middle of 1 and 2. So I guess we can say that's like a minute and a half after she leaves the house. And then the second 30 mile an hour occurrence is, let's go down till we hit the x-axis, and it matches up right in the middle of 2 and 3. So I guess that's the 2.5 minute mark. So she reaches 30 miles an hour at a minute and a half and 2 minutes and a half. So that's my final answer for my guess. Let's see if I'm correct. At t equals 1.5 and at t equals 2.5. Yep, I was correct. Good job, Ishikawa. Okay, let's look at D. How long did it take Leilani to get to the store? Okay, so we can assume that, okay, so this is a little bit different from the previous graph. So when we're at the bottom, it doesn't mean that we're at home or we're at the store or anything like that. When we're at the bottom, yeah, or we're touching the x-axis, that means we're just not moving. We're traveling at 0 miles an hour. So we can assume that when she gets to the store, she's going to be at 0 miles an hour again because, yeah, you don't want to drive the car into the store, right? So, yeah, we're going to assume that when Leilani reaches 0 miles an hour, that she's at the store. Yeah, we're not going to assume that it's, well, I guess we could assume she's at a stoplight or a stop sign, but it looks like this journey doesn't ever stop until she gets to the store. So she got lucky. She caught all the green lights, or maybe there is no green lights. There's no stoplights where she is, but all we can tell is, yeah, when she gets to 0 miles an hour again, which is right here, we can make the assumption that she's at the store, and that corresponds with what time frame? Looks like it's 4.5. Okay, so 4.5 is good. All right, let's look at letter E. Okay, so was Leilani ever traveling at a steady speed? And if she was, when did it happen and how fast was she going? Okay, so I think the steady speed that they're referring to is right there. Okay, that's your steady speed right there. Yeah, and I guess we can answer yes, she was doing a steady speed at one point during her journey. And when did it happen? It happens, looks like, between the half-minute mark and the 1-minute mark. Yeah. And how fast was she going? It looks like it matches up with 10 miles an hour. So that's my final answer. Yeah. Yes. Between 30 seconds and 1 minute and 10 miles an hour. That's my final answer. Yep. Good to go. And over what time interval was she accelerating? Okay. Accelerating means getting faster. Okay. So when was she doing that? So let's actually erase this circle because I don't need that circle no more. And that's not the circle I want to erase. I want to erase that. Okay, so when was she getting faster? When was she accelerating? So the kind of characteristic you want to look for is a graph that's rising. Yeah, because a graph that's rising means she's getting faster. So her graph is rising there, her graph is rising there, and her graph is rising there. So I guess these two circles that I circled at the end can be all part of the same answer. Yeah. And I don't want to circle any of the graphs that go down because that means she's not accelerating, she's decelerating. Yeah. So she's getting slower. So yeah, we can say that she's accelerating from 0 to 30 seconds. And then she's also accelerating from 1 minute to 2 minutes. Okay. And that'll be my final answer. Let's see if I'm correct. Yep, from 0 minutes to 0.5 minutes, and from 1 minute to 2 minutes. Yeah, all right. Let's look at our next problem. Okay, so this graph is going to show the company's or a company's monthly profit, which is the amount of money you make. Yeah, so you make money, then you pay all your bills, and that's pretty much your profits. Okay, and this graph is written in the unit of thousands of dollars. Okay, and it's as a function of the amount of money spent on marketing. Okay, so marketing basically is when you promote your company or whatever you're trying to sell. So you spend money on like TV ads or ads that you see pop up on Instagram or Facebook or on radio or in newspaper, magazines, websites. Yeah, that's all marketing. Money that you spend to get people to know about your product or your company so they say, oh yeah, I kind of like what I see, I'm going to buy it. Yeah. So what pretty much this graph shows is when you spend more money, you make more money. Yeah. But at a certain point, you just can't be spending endless amount of dollars to market your product because at a certain point people are going to be like, okay, I know about your product already. You've been advertising for like 20 million years, so I know already. And so there's going to be a point where you don't have to advertise as much anymore because yeah, people are going to know what your company and your product is all about. I mean, you still want to maintain advertising so that people know that you're still around, but you don't got to flood the market with commercials and pretty much like take over a whole show and all they see is your commercial. Okay, so there's going to be a certain point where too much is going to actually do more harm than good. Okay, and that's what this graph shows because it's going back down. So you're spending a lot of money, but the graph is going back down. Yeah, you're starting to make less money as you spend too much on marketing. So let's see what kind of questions we're going to get asked. So what is the company's monthly profit is if no money is spent? Okay, so no money would pretty much correspond to 0 on the x-axis. Yeah, because marketing dollars is going to be your x-axis going from left to right. Profit is going to be your y-axis going up and down. So if I don't spend any money, that means I'm 0 on the x-axis. So 0 on the x-axis corresponds to right there on the y-axis. So that matches up with 50. Yeah, because that's right in the middle of 40 and 60. So 50 is my answer, but you got to remember this is in thousands of dollars. So 50,000 dollars is going to be my profit if I don't spend anything on marketing. So you're probably going to say, yeah, that's pretty good. If I don't spend anything on marketing, I make $50,000. I'll take that. Yeah. But if you're a big, huge company, you're going to be like, no, I don't think so. I want to make more than that. Okay, and this is what this graph shows us, that there's going to be a certain point where if you spend the optimal or the best amount of money, yeah, then you're going to make the maximum profit that you can get. Okay, so how much money should the company spend on marketing each month? So when does the company basically make the most money? Yeah, so you're going to look for the highest point of the graph because that's when the company makes the most money. So the highest point of the graph is right there. And how much money corresponds with that dot? So let's go all the way down till we get the x-axis, and it hits right in between 1 and 2. So like 1.5. Yeah, so 1.5, and this is in thousands of dollars. So that's going to represent, how much money do you think? And hopefully you say it represents 1,500. And if you said that, then I think you might be correct. Yep, 1,500. So I spend $1,500 on marketing, then I can make, ooh, yeah, I can make a lot of money because that's where my graph maxes out. And that's what we want to see. What's the best amount of money we can spend on marketing so that we can maximize our profits? Okay? All right, so let's look at number or letter C. Okay, so what is the company's maximum profit? Oh, I always erase the dot and I have to use it again in the very next question. So let me just draw that dot back again. So what is the amount of money I make when I hit that dot that's way up there on the top? Let's see. It's right above the 80. It's one box higher than 80, so I can assume it's 85. Does it go by 5s or does it go by 10s? Oh, it goes by 10. Sorry. So 10, 20, 30, 40. Yep, it goes by 10. So that's going to actually match up with 90,000. Okay, so I'm going to be making $90,000. Wow, that's pretty good. I'll take 90 over 50 any day, right? And all you have to do is spend $1,500 more, or on marketing rather, and you make $40,000 more in profit. That's awesome. Yeah. Okay, letter D. Okay, so what is the maximum amount the company can spend on marketing, rounded to the nearest 500, and still have a positive profit? Okay, so I guess this graph doesn't show what happens if I start spending, if I keep on spending. Like this graph, I guess, is heading in a downwards direction, right? So after we hit our peak, it's going to start going down, and I guess if we wanted to draw this graph some more, I guess it would start moving down like that. Actually, let me get into pen mode again. It would start doing this. It would start actually going into the negatives. So yeah, we don't ever want to spend money and all of a sudden the marketing is actually irritating people by telling them, oh man, I see your commercial only on TV all the time and now I hate your company because all I see is your company and I'm having bad dreams. So that's kind of like the effect we don't want. So it says, what is the maximum amount the money the company can spend on marketing, run it through nearest 500, and still have a positive profit? So meaning that we stay above or right on the x-axis. So basically we want to know what is the dollar amount right there at that dot. Okay, so it's not exactly in the middle of 3 and 4. It's almost in the middle of 3.5 and 4. Yeah, so round it to the nearest 500. Let's see. Is it closer to 3.5 or is it closer to 4? Yeah, so 3,500 or 4,000. And let's see, let's get rid of some of these lines because maybe it is closer to 1, but I can't see it because I drew all these lines. So I think it's probably closer to 3.5. So I would try to guess 3,500 would be my answer if I'm going to round. Yeah, actually, yeah, you want to make it 3,500 because if I start going to 4,000 actually, then I'm actually in the negatives. So yeah, when you round, it's not a matter in this case where you want to round to see who it's closer to. Yeah, because if I round to 4,000, that means I'm in the negative already. And this question says I need to be in the positive. So actually I have to round to 3,500 because that'll keep me positive. If I go 4,000, I'm going to be negative in profit. And that's going to be exactly what the question doesn't say to do. So good thing I started talking aloud about that problem because in my brain, when I started saying it out loud, I realized, oh yeah, I don't want to have 4,000 as an answer because I'll actually be negative at that point. Okay, so if you got to do these problems and actually talk it out loud so that your brain actually hears what you're saying, because sometimes you don't understand something until you start hearing it spoken. Yeah, and you're gonna be like, okay, wait, that doesn't make any sense because what I just said doesn't make any sense at all. Yeah, so maybe people might think you're crazy because you're talking to yourself, but that's kind of like what I'm doing right now. Yeah, and it helped me realize that 4,000 is the answer I don't want. Okay, all right, so let's look at the last problem, I think. Okay, number 6. So number 6, this is a graph. Ooh, this looks kind of strange, this graph. Yeah, with all these circles and these horizontal lines. There's no diagonals at all. There's just circles and horizontal lines. Yeah. So this is a graph that shows the cost in 2013 of mailing a letter as a function of the weight of the letter in ounces. So if you didn't know, when you mail a letter, you can't just put anything you want in the envelope, yeah, and it's like super heavy and expect to pay like only like whatever the postage rate is nowadays, yeah. The more weight you have in an envelope, the more money you have to pay, yeah. So just keep that in mind. All right, so what is the minimum cost of mailing a letter, whether it's empty or just has one piece of paper inside there or something small, yeah? So what is the minimum you're going to pay if you just mail a letter, period? So let's see. The x-axis corresponds to weight in ounces. The y-axis corresponds to cost. So based on my first horizontal line, which is at the 46 cents mark, yeah, if I mail a letter that weighs anywhere from 0 to 1 ounce, I'm going to pay 46 cents. That's going to be my guess, 46 cents. Yep, and I was correct. Okay, so how much will it cost to mail a letter that is 2.5 ounces? So where is 2.5 ounces? So here's 1 ounce, 2 ounce, 3 ounce. Ooh, that's too far. So halfway. So 2.5 ounces is, let me get into pen, it's going to be right here. That's 2.5 ounces. So what horizontal line do I match up with? It looks like it matches up with 86 cents. So that'll be my final answer, 86 cents. Yep, and I was correct. Okay, so let's see, next problem. How much will it cost to mail a letter that is 3 ounces? So 3 ounces right here. And I'm going to go up and I'm going to go, ooh, whoa. There seems to be 2 places where I could potentially put my dot for 3 ounces. I could put it here, or I could put my dot there. So which line is going to get the dot that's going to tell me how much it's going to cost for 3 ounces? So this is where you got to understand your symbols that you guys probably learned a couple of years back in a previous math class, where I guess when you drew number line graphs, if it was equal to, you drew a solid dot that was filled in, and if it was not equal to that number, then you had to draw a blank dot or a hollow dot. Yeah, so kind of like what we have here up on the top, where we have a blank dot, meaning that this line goes everywhere right above 3 all the way up to 4. So this is like inequalities, yeah? So we can't, this line, this $1.06 doesn't kick in until it is after 3 ounces, all the way up until 4 ounces. Okay, the 86 cents line kicks in after 2 ounces, all the way up to and including 3 ounces. Okay, so these are those inequality line graphs that you guys drew a couple of years back where, yeah, you had to make open dots and closed dots. Yeah, hopefully you guys didn't forget about those, and if you did, then this might kind of trigger some memories that maybe you had back then. So as far as me drawing a dot though, I'm going to put it right there because I have a closed dot at 3 ounces. I cannot draw it up here because that's an open dot. It means that I cannot include 3 ounces in the $1.06 cost. Yeah, so it's going to be 86 cents instead. So that'll be my guess, 86 cents. And yep, I was correct. Okay, and last question. What can a letter possibly weigh for it to cost 66 cents? Okay, so 66 cents letter is going to be anywhere on this line. Okay, so let's see if I can read what this line is saying correctly. So it says my letters are going to be between 1 and 2 ounces. Can my letter be exactly 1 ounce? No, it can't be exactly 1 ounce because I have an open dot at 1 ounce. Can my letter be exactly 2 ounces? Yeah, I can't because I have a closed dot at 2 ounces. So a letter that weighs 66 cents is going to be for letters, I'm sorry, a letter that costs 66 cents is going to be for letters that weigh right above 1 ounce all the way up to and including 2 ounces. So let's see how I word my answer, because that's just me speaking out the answer, but there must be some other fancy way to write the real answer though. So, well, I guess it's just speaking out the answer also. So letter weighing more than 1 ounce up to and including 2 ounces. So let me actually write the answer with inequalities in mind. Okay, so let's see. Weight, that'll be in the middle. So we can It has to be less than or equal to 2. So it can be equal to 2, but it has to be less than 2. And it's also going to be greater than 1. Okay, so back in the day when you guys did inequalities, right, this line underneath the inequality symbol means it includes 2. 2 can be part of your answer. When it doesn't have the line underneath the inequality symbol, it means the 1 in this example cannot be included in your answer. But every number after 1 can be part of your weight value. Yeah, because I don't have that line written underneath the inequality symbol. So this can be, the weight can be anywhere above 1, but less than or equal to 2. Okay, so that's another way you can write this answer as far as the mathematical way. So in blue, we have pretty much like the written way, the spoken way of answering this question. Okay, so good luck with, I think you have 6 problems for homework. Good luck with that, and I will see you in class. Good luck. Bye-bye.